So hey guys, my name's Aman Muleva and I'm here again with a new video, and this video is going to be about introduction to the OSI model this topic is taken from networks. The OSI, which is an open systems interconnection model, is a conceptual framework used to understand network connections and standardize the functions involved in network process. We're gonna dive down into layer one. So there are seven layers in OSI model, and this here right now we're gonna speak about is layer one. Layer one, physical layer, transmission of raw data. Data transmission. The physical layer is responsible for the transmission and reception of unstructured raw data, typically in the form of electrical or optical signals. Hardware components. It includes hardware components such as cables, connectors, and network interface cards that facilitate the transfer of data across the network. We're going to speak up now about the second layer. The second layer is data link layer, error detection and correction. Error handling. The data link layer ensures error-free transmission of data by detecting and correcting any errors that may occur during transmission. MAC addressing. It also deals with the addressing of network devices through MAC, which is media access control, addresses and controls access to the physical medium. Layer 3. Layer 3 is network layer, routing and logical addressing. So routing. The network layer is responsible for routing data packets from the source to the destination across multiple network nodes. Logical addressing. It uses logical addressing such as IP addresses to identify devices on different networks and determine the best path for data transmission. Transport layer. End-to-end communication. Data segmentation. The transport layer segments and reassembles that the upper layers into manageable units for end-to-end communication. Reliability. It ensures the reliable and error-free delivery of data between the sender and the receiver through mechanisms like acknowledgement and retransmission. Layer 5. Layer 5 session layer, establishing and managing connections. So connection establishment. The session layer is responsible for establishing, maintaining, and terminating connections between applications. Session management. It also manages the ongoing dialogues or session between the different applications in a network. Security integration. This layer incorporates security features to maintain the integrity and privacy of the communication session. Layer 6 presentation. Data formatting and encryption. Data translation. The presentation layer translates data into the format that the application layer can accept, ensuring compatibility and uniform representation. Cryptography. It handles data encryption and decryption, providing a secure mean of transmitting information over the network. Layer 7. Application layer, user interface, and network services. User accessibility. The application layer provides various network services directly to the end user application and ensures user accessibility to the network. Service interaction. It facilitates interaction between network services and user application, enabling a wide range of functionalities and features. Comparison of OSI model with TCP/IP model. Different approach. The OSI model has seven layers emphasizing functionality, while the TCP/IP model combines functionalities with four layers for more practical implementation. Network protocols. The OSI is a theoretical model, whereas TCP/IP is the foundational protocol suite of the Internet today, being more widely implemented. Flexibility versus simplicity. OSI models allow a more detailed and flexible network configuration, while TCP/IP is simpler and more lightweight, ideal for internet usage. Conclusion and summary. Architectural understanding. The OSI model provides a comprehensive and systematic approach to understand the complexity of network architecture and functions. Standardized framework. It serves as a standardized reference model for network communication, ensuring consistency and interoperability across diverse systems. Global impact. Its widespread adoption has profoundly influenced network development and remains a cornerstone of networking education and implementation. Continued relevance. Continued relevance. Despite the evolution of technology, the OSI model continues to be relevant in understanding modern network infrastructures and protocols. Now I'm going to show you a pictorial representation or example on how the OSI model works. So this right here is network A to network B, where first we're going to connect it to a layer 1, which is a physical layer, converts binary into signals and transmits them over media, which is optic fiber right here. And layer 2 adds addresses to the data packet, letting upper layer access media. Now we're going to go to layer 3. Layer 3 is network, transmits packets between the network and determines the best path. Layer 4 is nothing but transport segments data from L5. It ensures data arrives correctly and at what rate. And then comes the last one, which is basically Layer 5 session establishes, maintains, and ends communication between the devices. Then again, Layer 5 also decides which packet belongs to which file. Layer 6 is a presentation that translates data to binary and encrypts and decrypts it. And seventh layer is apps like Skype use layer 7 application protocol, not only Skype, WhatsApp, and all these other apps also use the same network application protocol. This is it for today, guys. Thank you.